1. Describe the structure of the atom as a central nucleus containing neutrons and protons surrounded by electrons and shells. 1. Define proton number/atomic number as the number of protons in the nucleus of an atom. 2. Define mass number, nucleon number as the total number of protons and neutrons in the nucleus of an atom. 3. Define isotopes as different atoms of the same element that have the same number of protons but different numbers of neutrons. 4. State that isotopes of the same element have the same chemical properties because they have the same number of electrons and therefore the same electronic or configuration. Just 5. State that an ionic bond is a strong electrostatic attraction between oppositely charged ions. 6. Describe the properties of ionic compounds. A. High melting points and boiling points. B. Good electrical conductivity when aqueous or molten and poor when solid. 7. Describe the giant lattice structure of ionic compounds as a regular arrangement of alternating positive and negative ions, SC. 8. State that a covalent bond is formed when a pair of electrons is shared between two atoms, leading to noble gas electronic configurations. 9c. Describe in terms of structure and bonding the properties of simple molecular compounds. A. Low melting points and boiling points. B. Poor electrical conductivity. 10. Describe metallic bonding as the electrostatic attraction between the positive ions in a giant metallic lattice and AC of delocalized electrons. 11. Define the molecular formula of a compound as the number and type of different atoms in one molecule. 12. Define the empirical formula of a compound as the simplest whole number ratio of the different atoms or ions in a compound. 13. Describe relative atomic mass, R, as the average mass of the isotopes of an element compared to 1/12 of the mass of an atom of 12C. 14. Define relative molecular mass, Mr., as the sum of the relative atomic masses. 15. State that the mole is the unit of amount of substance and that 1 mole contains 6.021023 particles, for example, atoms, ions, molecules. This number is the Avogadro constant. 16. Define electrolysis as the decomposition of an ionic compound when molten or in aqueous solution by the passage of an electric current. 17. Identify in simple electrolytic cells. A. The anode as the positive electrode. B. The cathode as the negative electrode. C. The electrolyte as the molten or aqueous substance that undergoes electrolysis. 18. Describe the transfer of charge during electrolysis to include A. The movement of electrons in the external circuit. B. The loss or gain of electrons at the electrodes. C. The movement of ions in the electrolyte. 19. State that metal objects are electroplated to improve their appearance and E. Resistance to corrosion. 20. State that an exothermic reaction transfers thermal energy to the surroundings, leading to an increase in the temperature of the surroundings. 21. State that an endothermic reaction takes in thermal energy from the surroundings, leading to a decrease in the temperature of the surrounding. 22. State that the transfer of thermal energy during a reaction is called the enthalpy change, H, of the reaction. H is negative for exothermic reactions and positive for endothermic reactions. 23. State that bond breaking is an endothermic process and bond making is an exothermic process, and explain the enthalpy change of a reaction in terms of bond breaking and bond making. 24. Define activation energy, EA, as the minimum energy that colliding particles must have to react. 25. State that a catalyst increases the rate of a reaction and is unchanged at the end of a reaction. 26. State that a catalyst decreases the activation energy, EA, of a reaction. 27. State that some chemical reactions are reversible as shown by the symbol WSOL. 28. State that a reversible reaction in a closed system is at equilibrium when A. The rate of the forward reaction is equal to the rate of the reverse reaction. B. The concentrations of reactants and products are no longer changing. 29. State the typical conditions in the Haber process as 450 degrees Celsius, 20,000 kPa/200 atm, and an iron catalyst, 30. State the sources of the hydrogen, methane, and nitrogen air in the Haber process, 31. State the typical conditions for the conversion of sulfur dioxide to sulfur trioxide in the contact process as 450 degrees Celsius, 200 kPa/2 atm, and a vanadium V oxide catalyst, 32. State the sources of the sulfur dioxide, burning sulfur or roasting sulfide ores, and oxygen air in the contact process, 33. Define redox reactions as involving simultaneous oxidation and reduction, 34. Use a Roman numeral to indicate the oxidation number of an element in a cetane compound of CDs, 35. Define oxidation as gain of oxygen and reduction as loss of oxygen, D or A, 36. Define oxidation in terms of EDE, A, loss of electrons, CU where EB, an increase in oxidation number, 37. Define reduction in terms of very A, gain of electrons, B, a decrease in oxidation number, 37. Define an oxidizing agent as a substance that oxidizes another substance and is itself reduced, 38. Define a reducing agent as a substance that reduces another substance and is itself oxidized, 39. Define acids as proton donors and bases as proton acceptors, 40. Define a strong acid as an acid that is completely dissociated in aqueous solution, and a weak acid as an acid that is partially dissociated in aqueous solution. 41. State that hydrochloric acid is a strong acid, as shown by the symbol equation HCl H plus AQ Cl AQ, 42. State that ethanoic acid is a weak acid, as shown by the symbol equation CH3 COOH AQ H plus AQ CH3COO AQ, 43. Describe the neutralization reaction between an acid and an alkali to produce water, H plus AQ OH AC H2O, 44. Describe amphoteric oxides as oxides that react with acids and with bases to produce a salt in water, 45. Classify Al2O3 and ZNO as amphoteric oxides, 46. Describe the preparation, separation, and diluent purification of soluble salts by reaction of an acid with A. An alkali by titration, B. Excess metal, C. Excess insoluble base, D. Excess insoluble carbonate, 47. Describe the general solubility rules for salts. A. Sodium, potassium, and ammonium salts are soluble. B. Nitrates are soluble. C. Chlorides are soluble except lead and silver. D. Sulfates are soluble except barium, calcium, and lead. E. Carbonates are insoluble except sodium, potassium, and ammonium. F. Hydroxides are insoluble except sodium, potassium, ammonium, and calcium, partially, 48. Describe the preparation of insoluble salts by precipitation, stir, 49. Define a hydrated substance as a substance that is chemically combined with a water and an anhydrous substance as a substance containing no water, 50. Define the term water of crystallization as the water molecules present in hydrated crystals including CuSO4,5H2O and CoCl2,6H2O, while 51. Describe the periodic table as an arrangement of elements in periods and groups, and in order of increasing proton number/atomic number, Tocum, 52. Describe the change from metallic to non-metallic character across a period, 53. Describe the group 1 alkali metals, lithium, sodium, and potassium as relatively soft metals with general trends down the group limited to A. Decreasing melting point, B. Increasing density, C. Increasing reactivity, 54. Describe the group 7 halogens, chlorine, bromine, and iodine as diatomic nonmetals with A. General trends down the group limited to A. Increasing density, B. Decreasing reactivity, 56. State the appearance of the halogens at RTP as A. Chlorine, a pale yellow-green gas, and as D. B. Bromine, a red-brown liquid, C. Iodine, a gray-black solid, 55. Describe the transition elements as metals that A. Have high densities, B. Have high melting points, C. Form colored compounds, D. Often act as catalysts as elements and in compounds. 56. Describe transition elements as having ions with variable oxidation numbers, including iron 2 and iron 3. 57. Describe the uses of metals in terms of their physical properties, including grade A. Aluminium in the manufacture of aircraft because of its low density, B. Aluminium in the manufacture of overhead electrical cables because of its low density and good electrical conductivity, C. Aluminium in food containers because of its resistance to corrosion, D. Copper in electrical wiring because of its good electrical conductivity and ductility. 58. Describe an alloy as a mixture of a metal with other elements, including A. Brass as a mixture of copper and zinc, B. Stainless steel as a mixture of iron and other elements such as chromium, nickel, and carbon. 59. Explain in terms of structure how alloys can be harder and stronger than the pure metals because the different-sized atoms in alloys mean the layers can no longer slide over each other. 60. Describe the uses of alloys in terms of their physical properties, including stainless steel and cutlery because of its hardness and resistance to rusting. 60. State the order of the reactivity series as potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, gold. 62. Describe the reactions, if any, of A. Potassium, sodium, and calcium with equal cold water, D. B. Magnesium with steam, C. Magnesium, zinc, iron, copper, silver, and gold, with dilute hydrochloric acid, Yo. 63. Explain the apparent unreactivity of aluminium in terms of its oxide layer. 64. State the conditions required for the rusting of iron and steel to form hydrated iron 3 oxide. 65. State some common barrier methods, including painting, greasing, and coating with plastic. 66. Describe the extraction of iron from hematite in the blast furnace limited to A. The burning of carbon, coke, to provide heat and produce carbon dioxide, B. The reduction of carbon dioxide to carbon monoxide, idol, C. The reduction of iron 3 oxide by carbon monoxide, D. The thermal decomposition of calcium carbonate/limestone to produce calcium oxide, E. The formation of slag. 67. State the symbol equations for the extraction of iron from hematite. A. CO2CO2, B. CCO2 C. Fe2O3 Fe3CO2, D. KECO3CO2, E. CaOCO2 CaSiO3. 68. State that the main ore of aluminium is bauxite and that aluminium is extracted by CO2 electrolysis. 69. State that water from natural sources may contain substances including A. Dissolved oxygen, B. Metal compounds, C. Plastics, D. Sewage, E. Harmful microbes, F. Nitrates from fertilizers, G. Phosphates from fertilizers and detergents. 70. State that some of these substances are beneficial, including C3, A. Dissolved oxygen for aquatic life, some metal compounds provide essential minerals for life. 71. State that some of these substances are potentially harmful, including A. Some metal compounds are toxic, B. Some plastics harm aquatic life, C. Sewage contains harmful microbes which cause disease, D. Nitrates and phosphates lead to deoxygenation of water and damage to aquatic life. 72. Describe the treatment of the domestic water supply in terms of A. Sedimentation and filtration to remove solids, B. Use of carbon to remove tastes and odors, C. Chlorination to kill microbes. 73. Describe the use of NPK fertilizers to provide the elements nitrogen, phosphorus, and potassium for improved plant growth. T. 74. State the composition of clean dry air as approximately 78% nitrogen, N2 221%, oxygen O2 and the remainder as a mixture of noble gases and carbon dioxide CO2 75. State the source of each of these air pollutants limited to A. Carbon dioxide from the complete combustion of carbon-containing fuels, B. Carbon monoxide and particulates from the incomplete combustion of carbon-containing fuels, C. Methane from the decomposition of vegetation and waste gases from digestion in animals, D. Oxides of nitrogen from car engines, E. Sulfur dioxide from the combustion of fossil fuels which contain sulfur compounds. 76. State the adverse effect of these air pollutants limited to A. Carbon dioxide. Higher levels of carbon dioxide leading to increased global warming which leads to climate change. B. Carbon monoxide, toxic gas. C. Particulates, increased risk of respiratory problems and cancer. D. Methane, higher levels of methane leading to increased global warming which leads to climate change. E. Oxides of nitrogen, acid rain, photochemical smog, and respiratory problems. F. Sulfur dioxide, acid rain, CO77. Describe how the greenhouse gases carbon dioxide and methane cause global warming limited to A. The absorption, reflection, and emission of thermal energy. B. Reducing thermal energy loss to space, 78. State and explain strategies to reduce the effects of these environmental issues limited to A. Climate change, planting trees, reduction, hasitriu. In livestock farming, decreasing use of fossil fuels, increasing use of hydrogen and T-DE. Renewable energy, for example, wind, solar. B. Acid rain. Use of catalytic converters in vehicles, reducing emissions of sulfur dioxide by using low-sulfur fuels and flue gas desulfurization with calcium oxide, 79. Describe photosynthesis as the reaction between carbon dioxide and water to produce glucose and oxygen in the presence of chlorophyll and using energy from light, AC, 80. State the word equation for photosynthesis, carbon dioxide, water, glucose, oxygen, IBOEC, 81. Explain how oxides of nitrogen form in car engines and describe their removal by catalytic converters, for example, 2CO2 no 2CO2N2CC, 82. State the symbol equation for photosynthesis, 6CO2 6H2OC 6H12O6 602,